In section 3.1, we're going to start graphing quadratic functions. I've uploaded this graphing functions handout to our Blackboard site. For section 3.1, we'll focus on the left-hand column here on quadratic functions. In section 3.2, we'll be looking at the graphs of polynomial functions. That's what you see to the right here. But for now, we'll just focus on quadratic functions. We're going to use this 5-step method that the text outlines for graphing quadratic functions. And it can be used with functions that are in standard form and general form. All the steps are really the same for either form with the exception of the vertex. In standard form, you can identify the vertex hk directly from the equation that you see. In general form, we have to use the vertex formula, where the x value is minus b over 2a, and then we substitute that x value into the function to get the y value for the vertex. We'll go through each step of this procedure one by one, identify key information from steps 1, 2, 3, and 4, and then put all that information together in step 5 to plot the points that we get and draw the smooth curve of the parabola or quadratic function. Let's look at example 1 on page 348 from your textbook. And this is an example of a standard form equation. So I've included the standard form here, ax minus h squared plus k, so you can compare the actual equation with the form of the standard form. And what we can do, if you'd like, is just identify what the values of a, h, and k are. So here, a is minus 2, h is 3, and k is 8. So we can just identify those pieces when we get started. Okay, so let's look at the individual steps. Step 1 is identify the parabola direction. If the leading coefficient a is negative, the parabola opens in the negative direction or downward. If it's positive, it will open in the positive y direction or upward. So because a, which is minus 2 in this case, because a is less than 0, the parabola opens downward. In step 2, we'll find the vertex. Now in the standard form, that's a little bit easier than general form. The vertex is defined as this coordinate point hk. And so for our purposes, since we've already identified h and k, that will be 3, 8. Now, just note the definition of the equation has a negative here. So if you have, say, if this were x plus 3, that means h would be a minus 3. Minus a minus would be positive. So in that case, h would be minus 3. So just watch if you have a plus sign inside this part of the function. It really means that this value h will be negative and not positive. In step 3, we're going to find the x-intercepts. And so what we'll do here is take our function f of x and set it equal to 0. And this is where in this step, whether it's standard form or general form, this is where you're going to have to draw upon your skills or the techniques from section 1.5 on solving a quadratic equation. So what we'll do is we'll take our equation, minus 2 times x minus 3 squared plus 8, and set it equal to 0. So we need to isolate this x minus 3 squared term. So we'll subtract 8 from each side, and then divide by this coefficient of minus 2 to get to this step. X minus 3 squared equals positive form. Now, this is what I would call a favorable form for a square root property. If you notice, the variable x here is inside this square. So if we apply the square root property, that'll allow us to get to the x value a little more easily than, say, FOILing this out, then subtracting 4, setting the equation equal to 0, and trying to factor. So this is a good example to apply the square root property. When we do that, we will get this. X minus 3 equals plus or minus the square root of 4, which of course will be plus or minus 2. Don't forget those plus or minus roots with your square root property. And now when we solve for x will equal 3 plus or minus 2, which of course x will equal 1 and 5. Now we are going to graph, so I'm going to express those x-intercepts as coordinate points. And this will be the key information from step 3, our x-intercepts. Now step 4 is to find the y-intercept. So what we'll do is substitute 0 into the function. Substitute 0 into the equation of your quadratic function and carefully evaluate. So here we'll get minus 2 times minus 3 squared plus 8, which is minus 2 times plus 9. And eventually we'll get a value of minus 10. But remember, we're graphing. So write that y-intercept in coordinate point form. Now let's finish the problem and graph it. And what we'll do is put together all this information you'd see in red. We know the graph opens downward. We know the vertex is at the point 3, 8. X-intercepts at 1, 0, and 5, 0. And the y-intercept is 0 and minus 10. And so when you put all those points together on the graph, it should look, you should have a nice shape of a parabola along an axis of symmetry in the middle. And you should have that symmetrical shape. That's one way to diagnose if you had made a mistake. If one of your points isn't quite correct, the graph shape won't look quite the way it should. So if it doesn't look, always look at that graph at the end. If it doesn't look quite right, double check your work for the coordinate points you've calculated. Now try pencil problem 2a to practice graphing a standard form equation. Now let's look at an example of graphing a general form equation. Again, we're going to use the same 5-step method to graph the equation. The only difference will be here when we determine the vertex. We'll have to use this vertex formula to come up with the x and y coordinates. In example 3, we're given this function, f of x equals minus x squared minus 2x plus 1. Now it's in general form. And in a general form equation, I would recommend you just identify a, b, and c right at the beginning and calculate this quantity minus b over 2a, which we'll need for the vertex formula. So doing that in this case, we'll get the x value of minus 1. So we already have half the vertex. And in step 1, we'll look at the parabola direction. Since a is negative, it will open downwards. So when we determine the vertex, the x value would be at minus b over 2a, and then we substitute that value into the function f to get the y value. So for our problem, we know that x is minus 1. We need to determine f of minus 1 to get the y coordinate. So f of minus 1 will be minus 1 squared minus 2 times minus 1 plus 1. And then carefully evaluate your expression. This will be minus 1 plus 2 plus 1, which will equal 2. So our vertex will be minus 1, 2. In step 3, just like we did with standard form equations, we need to find the x-intercepts by setting the function f of x equal to 0. And if we were to set this function equal to 0, remember, with quadratic equations, you always want to try to factor them first if you can. That's the easiest way to find the roots. However, in this case, we can't factor it, so we'll have to use the quadratic formula. When using the quadratic formula, carefully identify a, b, and c, and carefully substitute into the quadratic formula. Again, I really recommend use these grouping symbols, especially with your negatives. Just substitute the values into the formula first, and then carefully evaluate. Eventually, we'll get to this expression, 2 plus or minus the square root of 8 divided by minus 2. Remember, we can simplify this radical. This is square root of 4 times square root of 2. The square root of 4 is a perfect square. It will become 2. And then we can cancel these 2's between numerator and denominator to come up with this simplified expression. Now, because we have a radical in this answer, we'll have to use the calculator to come up with the approximate values, which you would find would be minus 2.4 and 0.4. And again, I want to write those in coordinate point form. In step 4, we find the y-intercept by substituting x equals 0 into the function. And with the general form equation, that's a little simpler. In this case, f of 0 will really be this constant c that you'll see in your general form. So in this case, that value would be 1, right? These two terms just go away when x is 0. And again, in coordinate point form, that'll be 0, 1. Again, like our standard form equation, we'll take all the information from the first 4 steps. Parabola opens downward. We have the vertex, the intercepts, and then we'll plot them. And even these decimal intercepts, we can graph in an approximate manner. But we'll put all those points together, connect them, form the graph. And again, you should see something that is symmetrical right along here, right? We'll have this axis of symmetry around the line x equals 1. So again, that's a way to diagnose whether maybe you made a little mistake with your coordinate points. One other note too, when you solve for step 3, right, just remember that real roots or solutions of f of x equals 0 will show up as x-intercepts, real roots only. If you happen to go through a problem like this and you got complex roots, like you saw with some of the quadratic formula problems in section 1.5, any roots that have complex values or imaginary numbers with I will not show up as x-intercepts. You can still have a graph, but you would not have x-intercepts. Once we have the graph of the function, we can identify the domain and range if it's asked for. And for all quadratic functions, the domain is all real numbers. Realize there's no division by 0 or square roots in quadratic functions. And then the range for this problem, what's our smallest y value? Well, that would be minus infinity. And what's our largest y value? Well, that would be positive 2 at the vertex. Now do pencil problem 2b to practice graphing a general form equation.